Hello everyone. Today we will continue to explain the electrostatic precipitator, mainly from the structural form, selection of main components and electrostatic precipitators. Explain to everyone. The structural forms of electrostatic precipitators are divided into 1. Tubular and plate electrostatic precipitators. These two figures are schematic diagrams of a single tube electrostatic precipitator. Schematic diagram of multi-tube dust collector. This is also a schematic diagram of a tubular electrostatic precipitator. This is a related image. 2. Vertical and horizontal electrostatic precipitators. Everyone can take a look. Schematic diagram of vertical electrostatic precipitator. 3. Single zone and dual zone electrostatic precipitators. These two pictures, the schematic diagrams of the plate type single zone electrostatic precipitator, are as follows. Plate type dual zone electrostatic precipitator. Schematic diagram. 4. Dry and wet electrostatic precipitators. These two pictures, schematic diagrams of dry and wet electrostatic precipitators. The main components of an electrostatic precipitator include 1. Corona electrodes require low corona voltage, high corona current, high breakdown voltage. 2. Dust collection board. This is a schematic diagram of the dust collection board. 3. Airflow distribution device. The airflow distribution device requires uniform airflow distribution, reduce resistance, improving efficiency. 4. Dust collector shell ensures sealing, reduce air leakage. Air leakage reduces efficiency, causing equipment corrosion. 5. Power supply device. High degree of automation, stable and reliable, strong adaptability, life requirement of over 20 years. Selection of electrostatic precipitator. 1. Determination of performance parameters of electrostatic precipitators. Area of dust collector. This formula can be used for calculation. The area of the dust collector and the flow rate of the treated gas. Dust collection efficiency. The effective driving speed of particles is related. The cross-sectional area of the electric field is equal to Q divided by U, where Q is the processing gas flow rate, U is the cross-sectional airflow velocity of the dust collector. Number of channels for dust collector. Due to the fact that there is a channel between every two dust collection poles, the number of channels N for dust collection can be determined by the following equation. N equals Q divided by B, or N equals A divided by BH, where B is the spacing between dust collection stages, generally taken as 0.2 to 0.4 meters. H is the height of the dust collector, usually 2 to 15 meters. Q is the gas flow rate. Electric field length. L equals A divided by 2NH. Here, H is the height of the electric field working voltage according to actual needs. The working voltage U is generally calculated using the following formula, where U equals 250 kilovolt. The working current can be determined by the area of the dust collector. Calculate by multiplying A with the current density of the dust collector. Here is an example question. Design an electrostatic precipitator for treating gypsum dust. If the processed air volume is 129,600 cubic meters per hour, the dust concentration at the inlet is 3 times 10 to 2 kilograms/m3. Required dust concentration at the outlet reduced to 1.5 times 10 to 5 kilograms/m3. Calculate the required electrode area for this dust collector. Electric field cross-sectional area, number of channels, and electric field length. So at this point, we can use the content we just talked about to perform calculations. So at this point, we need to check the effective driving speed of gypsum powder, approximately 0.18 meters per second. According to the formula mentioned earlier, the area of the electrode plate can be calculated separately. Electric field cross-sectional area, number of channels, and electric field length. You can take a look at its problem-solving process. Selection of electrostatic precipitator types. The type and configuration of the electrostatic precipitator should be based on the nature of the dust-containing gas being treated. Decision on processing requirements. The most important factor is the dust-specific resistance. If the specific resistance of dust is moderate, use a regular dry dust collector. For dust with higher specific resistance, wide rectangular and high-temperature electrostatic precipitators are also used. If a regular electrostatic precipitator is still used, it should be stored in dusty gas. Add an appropriate amount of conditioner to it, for example, ammonia, water, etc., to reduce the specific resistance of dust. For dust with lower specific resistance due to jumping in the electric field, general dry electrostatic precipitators are difficult to supply. A cyclone dust collector can be added after the electrostatic precipitator or filter-type dust collector. That's the end of this lesson. Thank you all.